Dr. Jut Wynne is a cave scientist and conservation ecologist. He has led over 80 science expeditions in various locations across the world. He is an assistant research professor with the Department of Biological Sciences at NAU and leads NAU's Cave Ecology and Exploration Lab. So big hand for Jut. Thank you for coming.
Thank you, buddy. Over the past 2 decades, my research has been driven by my passion to help protect our natural world while helping to advance humanity's capacity to one day explore caves with robots. Tonight, I'm going to share with you all a collection of anecdotes and a process which I believe will be beneficial to helping you all to both promote personal and professional growth. So I became obsessed with caves when, in about 2001, I was working on my master's research, and I was studying bird habitat in southeastern Arizona, and I was modeling habitat selection of a select number of birds, which had absolutely nothing to do with caves. So during my first year of my program, I received an email from a buddy of mine. He was an archaeologist studying ritualistic cave use by the ancient Maya. And one of his study sites he described as having this enormous bat roost. And he also mentioned that the cave was being considered for adventure tourism. And because of that, he thought it would be a really good idea to have a biologist come down and evaluate the cave before it became flooded with tourists. And he had known about my growing interest at the time with bats and invited me to come down and join him. So although this project had absolutely nothing to do with my master's research, adventure beckoned and I responded. There are turning points, pivotal moments that help to shape and define us as humans. And those 2 weeks in Belize was one of them for me. I left Belize knowing that I was going to become a cave scientist. Now, since then, I've led over 80 expeditions around the world. And while I've continued to study bats, my research has expanded to include a bevy of cave-dwelling animals, from apex predators to the most diminutive cave-dwelling invertebrates. And I wanted to share with you all some of those discoveries. This is a composite image representing about 70 species we believe all to be new to science. Roughly half of those have been formally described. And by that, I mean, we went through the process of writing the papers, publishing the papers, and then ultimately birthing these animals to the world as new species. The remaining half are still awaiting description. And what's always struck me when I do this sort of work is that whenever I enter a cave that I know no one has studied before, and that happens a lot in my business, I get as giddy as a 5-year-old boy, because I know that I stand a good chance of finding something new. And this is a testament to some of that work right there. While I was preparing for this talk, for some reason, I kept returning to Plato's allegory of the cave. Now, in Plato's cave, prisoners were captured at birth, bound in chains, and bound in such a way to where they could only view the cave wall directly in front of them. And behind them were objects that were paraded behind them, and they were seeing the shadows of those objects. Now, to them, this was their reality. This was their truth. A pivotal moment occurs when one of the prisoners is released, actually drugged to the surface, according to Plato's account of this thought experiment that he created, and forced to see what the world really is like. And he was blown away. He realized that everything that he'd seen up until this point was a mere illusion, and that his perception was askewed. So his epiphany was short-lived. According to Plato, they recapture him, drag him back down into the cave, and he assumes the position where he was before all this happened. And he tries to explain that what he saw on the surface to the others that were still bound and did not see what he saw. Well, according to Plato, they laughed at him. They dismissed him as crazy. And to me, as I've gone through this process over the past 20 years, it's been a lot like, at least at first, looking at shadows on a cave wall. And actually, I've done that as part of my job too. But I actually saw this transformation occur because when I first started this business, I knew very little about what I was doing because I was green. And, when we all start out with something, if we don't have a lot of training, like in academia, typically folks just kind of push you into the deep end of the pool with no floaties and expect you to swim. And I did that okay. That project in 2001, I prepared the best I could, but I realized that I could have done better. So over the years, I've evolved in my thinking and the way that I conduct field research. And I have been able to elevate my science because of it. So what I've done here is I prepared what I'm calling Plato. This is an acronym for this process that I'm going to walk us through. The P in Plato stands for prepare. And what I've learned over the years is how long it takes to prepare for a given project is directly correlated to the complexity of the project. I can spend anywhere from days to weeks in preparation for a given research expedition. I develop a raft of preparation documents for this research, oftentimes much to the chagrin of people who are working with me because they then have to read everything that I wrote. But I create operations plans that describe everything associated with the project, from the objectives to the logistics and where we're staying and how we're doing the work and everything. I also have a safety plan that itemizes the risks that we could encounter. And we have mitigative strategies to help us prepare for those risks. I also have a checklist. I have checklists for everything, actually, because, over the years, even now, occasionally I'll forget something. And, having a list really helps. Having a list really helps us with just about anything, right? I'm kind of lost in the grocery store without one. Turning our attention to the L in Plato. It's learn. And I've further subdivided this into the ABCs of learning. The A in the ABCs of learning is having an absorbing mind, having a willingness to absorb information both from our environment, which a lot of times we do intuitively, but also to have a willingness to absorb information from others. In 2019, I was conducting a study in Belize, Runaway Creek Nature Reserve. And I had the opportunity to work with some of the most amazing people I could have possibly imagined to have a chance to work with. And one of our objectives for this project was to deploy trail cameras at caves so we could monitor wildlife use. And everything was going well. Our work was progressing. But one of the guys had a day off, so he took some time off. He went home. And we get into the field the next day with a slightly different team composition. And we quickly enter into this comedic routine as to who's got the rope. It's like, I don't have the rope, you got the rope. I don't have the rope, you have the rope. And we're kind of looking at each other. Finally, we realized that our friend who was in Belmopan, he has the rope. He didn't know it. It was in the bottom of his backpack. But we needed the rope because we were tying it to our trail cameras. Well, these guys all have doctorates from Jungle University. They know the bush like the back of their hand. And one of the guys walked over to a plant, which I later learned was a rhododendron. And he grabs some roots and he walks over and he just starts fastening the trail camera with the roots. And the lesson that I learned from this is, my gosh, the jungle provides, especially when you know how to extract the resources from the jungle like these guys do. I also had a bit of an epiphany of sorts where I saw that it kind of reinforced what I'd been thinking over the years, is the importance of working with local collaborators. Because the people that live in the environment where you're going to work, they're going to know the terrain far better than you could ever imagine to. The B in the ABCs of learning stands for beginner's mind. Now, martial artists and Zen Buddhists describe this concept as approaching each subject with the humility of a beginner. And by doing this, we abandon that fallacy that we're an expert with nothing left to learn. The C in the ABCs of learning stands for curious mind. Being a lifelong learner, tremendously important in life to know a lot or a little about a lot of different things, right? And there's a lot of benefits to this approach, and I'll mention a few here tonight. Firstly, it will improve self-confidence and self-esteem. It will also increase your cognitive ability and your memory capacity, and it can make you a more successful person. The A in Plato stands for adapt. Now, I've learned over the years that Murphy's Law is the rule and not the exception in the field. If anything can go wrong, it will go wrong. Vehicles break down, somebody gets sick. There's, the cave that you want to go into is flooded. That happened this past summer. And, or there's, disagreements amongst personnel. Any of these things can derail productivity. And I've learned over the years that it pays to be malleable, which is a great metaphor for life, right? How many times in our lives do we experience things beyond our control? And we can either resist it or we can just kind of go with it. So much easier to go with it. In 2016, I led a 3.5-month expedition to Rapa Nui, also known as Easter Island. And our charge was to search for and collect endemic insects that were native to the island and occurred no place else on the planet. Now, the reason why this is so important is about 1,000 years ago, Rapa Nui underwent what is called a catastrophic ecological shift. And when this happened, the ecosystem shifted from a palm-dominated scrub forest to a grassland. And this coincided with the arrival of humans and a prolonged drought. And all of this became the perfect cocktail for immense change on the island, including the extinction of all terrestrial vertebrates. So today, the native fauna is represented by invertebrates, insects. So we were going to some of the most difficult to access parts of the island, and this included caves and cliffs. And when we were doing our cliff work, before we just jumped off a cliff, we wanted to conduct reconnaissance so we would know what we were getting into. So as part of this work, we went to the cave, went to the cliffs, we assessed which ones we would like to study. And we're also looking for natural anchors. We wanted to know where we could secure our ropes. Well, we quickly realized that the cliffs that we wanted to study, there were no anchors around those cliffs where we wanted to study. So we had two options. We either had to abandon that component of the work, and I didn't want to do that because I really wanted to drop a 1,000-foot cliff, or we had to adapt, and we chose the latter. Oh, that's unfortunate. Well, trust me, there is. Oh, golly. Well, there is rope that is secured to the front end of the vehicle. Trust me. So anyhow, what we did is we secured the rope to the front end of the vehicle. We chalked the tires, and then we applied the parking brake, and we had our own mobile anchoring system, which enabled us to conduct the research in a relatively safe fashion. For those of you all wondering what's on the end of those imaginary ropes, hey, wow, that was cool. Here I am about to drop about 1,000 feet off of this cliff. Now to the T in Plato, this represents think but more specifically, think positively. Now, the benefits of positive thinking have been embraced by Eastern traditions for millennia. And I've been a student of several of these Eastern traditions over the years. So I knew a bit about this idea of having a positive mindset, from that perspective. But as a research scientist, I wanted to know about it through a scientific lens. So I went to the literature, and this is what I found. Over 30,000 papers on positive thinking, the benefits thereof, have been published since 1952. And I wanted to share one of those with you all. This study was conducted by a Japanese team, and they had two test groups. One test group was they were listening to positively themed music, looking at positive images, puppies and kittens and that sort of thing. And the other group listened to the Japanese Constitution. Once this was done, they then completed a questionnaire. And this is what the researchers found. They found that those who were exposed to positively themed media exhibited more flexible thinking, and they were also able to generate more unconventional and atypical ideas. And if you think about it, if we go back to the A in Plato, that ability to adapt, what happens if you go into the field with a positive mindset? You're going to be more inclined to be able to MacGyver your way out of a bad situation should one arise. So through fastidiously preparing, applying the ABCs of learning, adapting as situations change on the ground, and choosing to think positively, I'm providing here a winning formula for overcoming adversity. Now, when you boil it all down, overcoming adversity is all about grit, right? That doggedness, that sheer determination to push through. And we all have it within us, that capacity to push through. Some of us have to dig a little bit deeper than others, but we're all able to do that. We can all muster that grit. I had a personal challenge that I had to overcome in September of 2008. I lost my grandfather. And, my biological father has never been part of my life. And this man was my dad. He raised me, taught me everything I know, took the belt to me when I deserved it. And so anyhow, I had to return to Georgia for the funeral, and I to be with my family. But I had to quickly return home because I was preparing for 3 back-to-back expeditions that were going to carry me through the rest of the year. I was working in New Mexico, then northern Chile, and then I had to go to Rapa Nui for a few weeks. I had no choice but to dig deep and to tamp down my grief and just to push through, because that's what he would have expected of me anyhow. Also, what's I've learned to be critically important is working with the right folks. I've been incredibly blessed over the past 20 years in working with some of the most talented, intelligent, and just wonderful human beings. And I also have to admit that I wouldn't be speaking to you all tonight were it not for these folks. They brought the magic. They supported me. We worked well together as a team and were able to make things happen. Now, I shared with you all some of our discoveries associated with the invertebrates. I wanted to share a few more with you all. Since 2020, we've been studying wildlife use of caves using trail cameras, and we have 3 noteworthy observations. This is the very first footage of a bare-throated tiger heron hunting in a cave. And this animal is a juvenile. You can tell by the plumage. Juveniles in this stage, they have a tiger-striped appearance. We also collected additional information that helped us in developing a paper on cave-dwelling crocodiles of central Belize. And finally, and this to me is the most scintillating of them all, this footage. Female jaguar kills a peccary, drags it about 300 feet into a cave. And then she returns to the surface. A few minutes later, goes back into the cave. About 20 minutes later after that, her cub appears. Apparently what she was doing was she was telling Junior that dinner was on the table. And The two proceed to feed underground for several days, only returning to the surface a couple of times. We've also made several contributions to the study of planetary caves, caves beyond Earth. Since 2007, we've published about 30 papers on this topic, exploring various facets of this subdiscipline. One of our studies involved collecting thermal imagery from this aircraft that we used to develop models to predict where we could find caves on the landscape. Now, the reason why this is so important is because lunar caves provide us with a great potential for astronaut shelters. They provide protection against deadly cosmic radiation and could also provide us with access to water ice. On Mars, there are similar benefits for caves there, but they also represent one of the best locations to look for evidence of life. Now, this Plato process, this came straight from the School of Hard Knocks, making mistakes, a lot of dumb ones, and recognizing what works, what doesn't work, and iteratively improving as we went through time. This process, I believe, is useful to everyone in preparing for your journey, in applying the ABCs of learning, adapting when that ever-changing landscape of life presents us with things that we have to deal with, choosing to think positively, and overcoming the obstacles in your path. So when you embark upon your next expedition, be it in the classroom, the boardroom, the office, or the vast wilderness of life, throw the Plato roadmap in your backpack, because I believe it's a universal guide that can help you all to forge your own extraordinary trail. Thank you very much.
Thank you, Jut.
Oh, I'm not done yet.
You're not going anywhere. And I'm actually, you stay in here, we're going to share a rectangle
Okay.
together. You get really close if you want.
Wow.
Well, that was a great
Okay.
talk. Thank
Thank
you
you.
so much. I think that was, I had my wife over there telling me how much she likes checklists and was very happy to hear.
Ah, okay, yeah.
Thank
So it's
you.
not just you that uses them, right? Yeah.
I am given lists as opposed to making my own. So we're about the same age. And so I'm guessing you have a good 20 years spelunking left. At least. At least.
At least.
What do you have on the horizon? And not just kind of where you might be going, but what kind of knowledge are you trying to generate, to learn, to share with the world?
And what I have like 20 seconds, right?
A little bit of time.
All right, so there's a lot of things on the horizon. Yeah, we should always be looking for what's on that hill beyond, right there. What's on that next hill? So the first project that I have that we'll be starting next year, we're going to Bhutan. And Bhutan is in Central Asia. It is on the foothills of the Himalayas. And we're going to be conducting the first cave study ever conducted in the country. And the objective of this study is, one, to begin to characterize the animals using caves, much like you saw in the slides here. And we're also going to be working with the local communities and going to universities to try to kind of encourage them to start studying caves. We also have a proposal that we're putting in a couple of weeks here. Well, maybe longer given the impending government shutdown. Should the NASA gods smile upon us, we'll be returning to Hawaii in the summer.
Sounds like a lot of fun. Sounds like a lot of fun and a lot of interesting work ahead of you. So I want to say again, thank you for sharing your work and your perspective with us. I think we can all learn something. And I would tell you from the conversations that we've had just preparing for this event, and that's something I didn't bring up to you guys, that the SciTalk speakers, it's not just hey, do you want to give a talk in September? Come on down, talk for 15 minutes. There's a lot of work that goes into this. Spend time with every single speaker, talking about what they want to share, working through their story. And I hope you can tell from Jut put a lot of work into his presentation, and it was a great one. So thank you.
Thank you. So get this though, I get the email from him to do this. And then, I was like, it's kind of short notice, but okay, because I'm a glutton for punishment. So I decided to do it. And then he sends me this book, Talk Like Ted. I'm like, it's like pouring salt in a wound. I'm reading it and it says, oh, well, this person, they prepared for 6 months. This person had 100 people feeding into how they were designing their talk. I'm like, thanks, dude. But yeah, so there was, as he pointed out, there was a lot of work that went into it. And I really appreciate the opportunity to speak for you all. Thank you. Thank you very much.
Thank you.
Thanks, brother. Great. Appreciate it.
Thank you.
I'm gonna leave this.
Yes, no, actually, yes, leave that there. Thank you. Okay. Up next, Bobby Long. Bobby's zoologically focused artwork has been exhibited throughout the United States and internationally. In 2013, he became Arizona's first and only finalist in the internationally juried Adobe Design Achievement Awards. His illustrations have been published by Frontiers in Microbiology, Manifest Press, the Confluence Center for Creative Inquiry, and Edible Magazine, among others. Currently, Bobby teaches graphic design at NAU. Come on up.
Visual thinking and different modes of observation can help us to really connect to anything that we're looking at. In my case, it's probably an underrepresented organism. I think of myself as a visual artist more than anything else, but I have a special interest in biological subject matter. But I approach my subject matter kind of like a science illustrator. This means that I really try to understand what I'm drawing and to share that understanding. Curiosity will push me in for a closer look. And a science illustrator will put clarity above all else. More important than photorealistic lighting effects is illuminating all parts of the subject. Here we see a native oak leaf grasshopper adorning the first non-photographic cover of this journal. My next assignment was a full-page illustration to accompany a Gary Nabhan article about helping migratory pollinators. Here, instead of just restating the author's insights, I wanted to expand on what the author had to say. I wanted to provide more information. And I thought that I could do this with the language of images. So I chose one of the characters from that article and decided to offer a closer look. This is our apex pollinator, the honeybee. And honeybees have a slight static charge on their bodies. So when they land on a flower, pollen literally hops onto them. Kind of like those little annoying pieces of styrofoam that cling to your favorite black shirt, right? It's like the dog hair of the animal world. At the bottom of this illustration here, I have some line drawings that I also included. And these show the different tools built into the honeybee for what I call pollen management. We have things like an eye brush, we have an antenna cleaner, and even a little compactor built into the hind legs for compacting pollen. A science illustrator will often look at lots of samples and different angles to really distill and condense this information into a compact, understandable summary. These are some photographs that I took while visiting an insect collection. So I was just gathering some reference for the last two projects you saw. Now I do prefer to work from observation, and I was able to observe some of these insects, but it was really nice to cut down on the eye strain by having something that was a little larger than half an inch to stare at. And when I take this approach to my illustration work, my work usually starts on paper, and I like to draw in pencil, graphite pencil. When my pencil drawing is all done, I pop it into a flatbed scanner, and this digitizes the print for me, or the drawing for me. I'm kind of a light-handed drawer, so I boost the contrast quite a bit, and then I use a digital drawing stylus and little tablet to digitally paint in layers of color. So the end result is a landscape of textures and details living underneath a translucent skin of color. And in this particular project, there was a little money left in the printing budget for a custom blue ink and a really cool thing we call a spot gloss, where we just apply a high varnish to one part of the cover. So I chose the eyes and the brain of this moth. To some tech-savvy artists, working digitally might make the most sense from start to finish. For me, I prefer to do my thinking on a paper playground. Here we can see a few examples from my sketchbook. I think of drawing a lot like writing, in that it's a way to put your thoughts onto a surface that you can actually look at. And it's a really nice way to visualize what you're thinking and organize your thoughts. So whether I'm at a natural history museum or an aquarium, or maybe an animal refuge, I prefer to draw from live observation whenever possible, rather than using a photograph that's already been flattened two-dimensionally. And I find that this mode of drawing, this unmediated form of observation, really feels like the most human way to experience an object or a living subject. It helps me to better understand how that thing occupies three-dimensional space, and it also can help me understand how it moves through four-dimensional space when there's time and movement involved. So these are a mixture of pencil, and there's also some dirt cheap ballpoint pen in there as well. It's a pretty portable combination. And nobody tries to steal your fancy pens either. So I think ballpoint is a really wonderful material. I think it's a little bit underrated. I carried live observation and ballpoint pen into this project that I called Groundword. And I created this as the first artist in residence at a riparian preserve just north of Tucson. Groundword is a collection of 10 observational studies of ant nest openings that survived summer monsoons of the Sonoran Desert long enough into the summer to be drawn and remembered. So if you want to get touchy-feely about it, this is a way for me to document my kind of quiet time and space that I shared with some ants. No uncles. So again, these are ballpoint pen drawings. Below each of these, I have some little field notes, mostly observational stuff, things that I was hearing, like thunder rumbling over the mountain, things I was smelling, like that ozone, like creosote resin smell when the first raindrops touch the earth. And as I was drawing these, I tried to also eliminate as many variables as I could to really create a uniform perspective for all these. Eliminating unnecessary variables is another science illustration tactic. So to that end, I made sure that I observed all of these from about 2 feet away, sat on a little stool. I drew all of them at life size, so on average about 6 by 6 inches. And I figured out where north was. I figured out the north side of each of these little ant holes and aligned that with due north on a compass. All right, so back to those little notes again at the bottom. Aside from some little musings and ruminations, you also see the number of the ant nest. So I could revisit it on my little map that I drew. And you will also see the species of ant. I figured out what type of ants were making these. You'll see the time, the date, and you'll also see down there a set of geographic coordinates. That was just to help pinpoint the site of this very temporary architecture. Now, in drawing these, I employed another science illustration tactic, even though this was kind of more of a fine artsy project. I had to sift through lots of visual noise and then figure out parts that I wanted to emphasize. Okay, sifting through the noise and finding the important bits. I had taken a few reference photos quickly of these, just in case the rains came early, or in case a clumsy naturalist stepped on one or something, which I didn't do. But these photos were awful. They were terrible reference. They didn't convey depth well at all. The texture in them was overwhelming. Everything was in sand, and I'm under the bright desert sun, trying to look at little details inside of a minuscule cavern. It was just really hard to see what I was looking at. But the human eye and also a pair of sunglasses really saved the day, because the human eye is a dynamic aperture, so changing contrasts quickly isn't a problem. And maybe more importantly, the human eye can really shift its attention to different landmarks that help define form. So while we're staring at the ground, looking groundward, if you will, why don't we dig a little deeper beyond the parched surface? An organization called the Soil Food Web School approached me to create their official artwork for an international conference about regenerative farming and agriculture, and by extension, biodiversity in soil. So I did some research, visual research, and some reading, and figured out some of the beneficial microorganisms that this organization wanted me to illustrate. And I ran my sketches by the client, and after getting approval, I felt comfortable moving on, which for me means taking a closer look. Now, these things are really tiny. You can see some universal scale bars on these. Reading, if you see a weird symbol there, that's very, very, very tiny. It's much smaller than a centimeter. We have micrometers, we have nanometers, all kinds of tiny measurements for these minuscule beasts. So I had to look at microscopy or microscope images. And I actually looked at 2 different types of microscope images. Here you can see something that's probably more familiar to you, optical microscopy, whose colorful subjects display a backlit transparency. because the image is made by light passing through these things. Okay, when I was a kid, I tried to look through a carrot slice or something, and I realized I had to make that thing like as thin of it as a sheet of paper so I could actually, see through it, right? It's optical microscopy. These have that really nice transparency, full color. The downside is that really shallow depth of field. And that means that whatever we're looking at comes into focus as a really tiny, shallow sliver of space. So for that reason, I also looked at another type of microscopy, scanning electron microscopy, whose subjects don't have any kind of transparency to them. They appear very opaque because they're being bombarded by electrons rather than visible light. But the upshot is that the images produced by this process have, I guess you could say, a really incredible depth of field. It's also worth noting that electron microscopes and our most powerful deep space telescopes gather data and produce grayscale images that require color to be added in afterward by some kind of interpreter, maybe software, maybe a human interpreter. Color aside, my goal here was ultimately to visually strip away all of the soil in a sphere-shaped sample of beneficial microfauna. And these really charismatic buggers are all swirling around, having a little party around some fungus-enhanced root tips. So I guess you could say that I tried to make up for the shortcomings of each type of microscope by combining the best of both worlds in my drawing. I also leaned on some electron microscope reference in drawing these adorable bug heads. I mean that, they're adorable. A science center needed some really generalized insect heads to showcase 4 main evolutionary pathways that gave rise to the main categories of insect mouthparts. That was a mouthful. That was mouthful. So we have, I guess you could say, sponging mouthparts or lapping mouthparts on a generalized fly. We have chewing mandibles on a generalized ant. We have siphoning mouthparts on this little mothy fellow. And everybody's favorite, piercing mouthparts on a mosquito. I imagined all of these and kind of recombined them with my reference and in my head, all at the same angle to really get rid of that extra variable when trying to draw a comparison between all of these. Also, I applied a really muted color to the heads to downplay the changes in shape there, or the different head shapes, but used this really bright blue color to highlight the variables we're supposed to look at, the mouth parts. The museum director came to me again and said, hey, can you also create a big welcoming presence for the entrance to the entire insect exhibit? Bless you. And this would be, I guess we would kind of refer to this thing as the welcome bug. Needs a theme song or something, I don't know. So this would become a 2-sided illustration that would stand 5 feet off of the ground. And I was given quite a bit of freedom in actually choosing what to draw for this. Bounced some ideas off of the the director, and I arrived at a type of beetle. And to be specific, this is a type of jewel scarab. Okay, don't ask them about rolling dung balls. They don't want to hear about it. I chose this in part, for one thing, it doesn't have big scary jaws or something. But I also really like the white gold and brushed copper paint job. Now, if I wanted to live a simple, easy life, I would have drawn this head on with maybe kind of a symmetrical point of view or a symmetrical stance. But instead, I proposed something that was a lot more challenging to pull off, and that was building some personality into the stance of this beetle, having some asymmetrical movement, and also trying to achieve a little bit of three-dimensional depth and tilt in there as well. That was especially difficult because these two illustrations had to have the exact same silhouette since they were on either side of a cutout. So after lots of sketching and hours of staring at this little beetle on my desk, woo, Friday, I feel like I arrived at pretty accurate anatomy and was able to combine a real natural range of movement in the joints with a really healthy dose of humanity, in part with this, this kind of human stance. So I've addressed several science illustration tools and tactics today, clarifying, condensing, sifting to emphasize, opening up inaccessible spaces, and even adding some approachable humanity. I feel that all of these really come together in a culmination in my final example today, and also bring a few more little tactics to the table. This is Symbionts. Symbionts was a personal project, so another project that wasn't commissioned. And it had a three-dimensional half, three-dimensional sculptural component, and the other half was two-dimensional illustrations. So with the topic today, I'm going to focus on the two-dimensional half. And Symbionts, the title I chose for it, comes from the word symbiosis, which is the living together of unlike organisms. So I've got 5 different symbioses in the ocean here, 5 different pairs of symbiotic organisms. And some of them are parasitic, right? That means we have one organism taking from another without permission either, taking from another without killing the host. Some of these are a little happier. Mutualism, that's when both organisms benefit from the symbiosis. So we'll start things off with parasitism because it's about dinner time and I think we deserve it. I give you the tongue-eating louse and the red snapper. The tongue-eating louse is a pill bug-like isopod, and when it's small, it swims in through the fish's gills and latches onto the tongue. From there, it getting kind of queasy just talking about it. From there, it feeds and grows on this necessary organ. Yes, fish do have tongues. Feeds on this necessary organ until the tongue actually shrinks away. And at that point, the louse itself replaces the tongue. I'll draw it, just don't make me touch it. Beneath the full color artwork, I have some diagrams that I drew that I feel visually tell this story. And I'm also using yet another science illustration tool here. We call this the cutaway view, which affords us a look at the inside of something while simultaneously showing the outside as a point of reference. Let's do another parasitism. This is the crowd. I can hear the crowd loves it. So we have another pair here. The larger of the two is a Portuguese man of war. And that's basically a fused colony of little simple gelatinous animals all floating together, kind of like a pirate ship. The largest of these is gas-filled, and that keeps the organism afloat. And there's also a little sail, so it catches the wind like a sailboat. There's no motor or anything involved. Right, so this thing just floats along on the surface, passively catching any clumsy fish in its long, stinging tentacles, which can get much longer than what you see here. These stinging tentacles are loaded with thousands of specialized stinging cells. Each of these is spring-loaded and contains a venom-soaked harpoon that fires upon contact. And that can be really bad news when you have hundreds or thousands of these things firing into you at once. But our hero, our parasite, the blue dragon sea slug, swallows air, floats upside down on the surface to feed on the tentacles. And it can do this without triggering the stinging cells, without setting off these little harpoons. In fact, it's so specialized at this type of feeding that its body can pass these stolen weapons into its own appendages for its own self-defense. But enough with these cunning parasites. It makes me think of politics for some reason. Why don't we wrap up with a mutualism in the name of teamwork and collaboration? The golf ball-sized bobtail squid buries itself in the sand during the day to get some shut-eye, to sleep. At night, this little squid comes up, goes for a swim to hunt. But so do its predators. To a predator swimming underneath this little squid, a little silhouette against the moonlit surface would make for a very easy target. So there's a workaround. Nature is just one big arms race. The squid has a specialized organ, and it looks like this when the squid is a juvenile. And this organ's job is to first take in seawater, and then it isolates just one specific strain of bacteria from that sample. It then cultivates that bacteria. And it does this because that specific type of bacteria glows in the dark when it's fed. So for the rest of the squid's life, this organ has a pretty simple job. It just has to provide a home and tasty food for this colony of bacteria. Okay, it's a mutualism, so there's got to be some kind of trade-off, right, or a payout. So in return for a home and for food, the bacteria gets light. The bacteria produces light, which hides its silhouette against the moonlit surface. As the squid gets a little bit older, those appendages on the organ shrink away, and we see the mature organ here as just two lobes, kind of like beans or something. Now, as if all of that wasn't incredible enough, there's more. Beneath this light organ is the ink sac, which this species of squid can contract and expand. And it acts basically like a dimmer switch. That means that the squid can control the amount of light coming out of the organ to match the ambient light of any moon phase. I hear some wows, and I feel the same way. So this is another one of those little illustrations at the bottom of the larger print there. I've boiled away a lot of the extra details and things. You know, we don't have to look at any guts or anything to see what's inside this squid. I've also compressed time, right? I'm showing a process in a sense. And I've also taken out other variables that might cloud the way we interpret the stages of what's a really elegant natural process. And I may have humanized that squid a little bit. I think he's a cutie pie, but I think that's accurate. So I hope that you've found at least something today that's sparked your curiosity enough for your own deeper dive, maybe through drawing, maybe through further reading, maybe a nature documentary, or maybe taking a moment for some really close, focused, thoughtful observation. Curiosity can show us something that we never knew existed. But the more we learn about that thing, a fish, a bug, the humble microbe, the more likely we are to care about it. Thank you.
Thank you, Bobby. It's terrific.
Thank you.
So the first slide and the last slide are of a googly-eyed fish. And I'm guessing a few of you guys noticed this slide, but Bobby didn't say anything about this fish. We saw a different fish, one that was missing a tongue. We've had a few conversations, and what I've learned from those conversations and from this presentation, at least an appreciation of looking when I see a scientific illustration, what is it that the drawer, the illustrator, what have they observed? What are they trying to accentuate? What do they want us to notice and learn? And so I see this and I see googly eyes. And that's what pops out to me. So what is it that you found interesting about this? What is it you're trying to share with this image?
Well, this was, just to give a real quick backstory, the museum that asked for those insect heads and the big welcome bug more recently asked me to do some large deep sea illustrations for a permanent display in their ocean exhibit. And so there are 6 of these. This was my favorite one. And yeah, you caught on to the googly eyes. It's kind of hard to miss those, right? They're a little creepy. And I thought it was just kind of a nice choice for something, you know, a presentation about looking and drawing. So that definitely caught my eye first. Something I found even almost more interesting about this is that this type of fish, called a barrel eye fish, actually has its eyes inset inside of its head, and it actually is looking through a cockpit-like forehead. So those, again, those green orbs are trying to gather a lot of light down in the deep ocean. They're aimed up at the surface, so it can steal food from jellyfish and things. And it's got this clear cockpit-like head. Yeah, and its catchphrase is, "My eyes are up here," I guess.
All right. Well, thank you.
Well, thanks, Brandon, and thank you, everybody.
Really enjoy the talk. Okay, we are going to have about a little over 5-minute intermission, just to get a chance to switch out the microphones, make sure our next speakers are situated. In those 5 minutes, grab a drink. There's water, beer, wine, other things. Take a quick spin through the exhibit, and then when you start hearing some more science jokes, it's time to get back in. Okay, see you all very soon. So let's get started. We have 2 more speakers. The first, Dr. Inés Montaño, who is a theoretical condensed matter physicist by training and currently is the interim applied physics and material science department chair at NEU, leads the research group Quantum Photonics and Emerging Phenomena. She originally came to the United States from Germany for a postdoc at Sandia National Laboratories. So I'd like a big round of applause and a welcome to Inés.
Thank you. All right, so before I talk about the spooky and the weird parts, So let's talk about why you would even care about quantum 2.0 or quantum in general. And I brought a game to talk about this. So you see these 9 tiles right here, right? With all these different cats. So the goal of this game is to arrange these tiles so that every cat has the right head and bottom in the right color. So you have 9 tiles. I did this for the first 3 rare. You have the blue cat and the yellow cat. And the other ones are missing still. So you have 9 tiles and you have these 9 spots for these tiles. So you might think about, well, how many different possibilities could there be? I only have 9 tiles. But since every tile can go in each of these spots and every tile can be turned, there are actually quite a lot of possibilities. In fact, there are 95,126,814,720 possibilities for these 9 tiles. We have found one solution so far. There might be more. But if you're going through all of these 95 billion possibilities, that's probably going to take a while. So we want to use a computer to do this. Well, the computer would take 24 hours to go through. Sounds pretty good, 24 hours with 95 billion possibilities. What if we could do this faster? What if we could do this, let's say, in a second? 95 billion possibilities in 1 second. That sounds like science fiction, right? It sounds like such an incredible speed up. Well, that's where quantum computing comes into play. So this is a quantum computer, and it doesn't look like the computers we know. A quantum computer is a machine that uses quantum physics, phenomena from quantum physics, to do calculations, to do computations. And it looks very different than the computers we know. But what is quantum physics? So when we say physics, we usually think about classical physics. So things like, why is the sky so blue? Or what happened to his hair over there with this balloon? Those are things we learn in school, and that's classical physics. Quantum physics is something different. That's the physics of the subatomic world. So we're talking really, really tiny things, atoms and smaller. And it's actually really hard to picture how small an atom really is. So I brought this here, and hopefully this will help a little bit. So I'm holding a lot of things, but picture I'm holding a little tennis ball, like in this picture here. And on this tennis ball, I put 1 atom, 1 single tiny atom. So you wouldn't be able to see this because it's so tiny, right? And now I take this tennis ball and I grow it. I keep growing and growing and growing until the tennis ball has the size of our Earth. So now it's huge. This atom that was growing with the tennis ball, that would now be the size of a tennis ball. So if you imagine looking down from space onto Earth, and somewhere on Earth is a tennis ball, that's how small this atom was on the original tennis ball. So we're really talking incredibly tiny, tiny things. And when we're talking about things of these scales, these tiny, tiny things, that's when quantum physics comes to play. And really, since the beginning of the 20th century, that's when we have started to discover how these things work. And this picture here, that's from 1927, and in the middle there is Einstein with a lot of other people. And those were all the people who found a lot of these quantum rules and figured out how things worked at these tiny scales. And fun fact, there are 29 people in this picture, 17 of these got a Nobel Prize at some point. So it says a lot, right? And the discoveries that they made, we actually feel those because that's where we have computers. That's where we have lasers. That's where we have the internet and many other things. And so this was what we call the first quantum revolution. And these technologies, these are what we call quantum 1.0. But what about quantum 2.0? So I said earlier, spooky and weird. I'll talk about spooky and weird and how spooky and weird are driving this next technological revolution. So when you hear spooky, you might be thinking something like this, especially right now with Halloween coming, right? So quantum, that's not about ghost. So spooky and quantum means something different. This is a picture of 2 dice. There seems nothing spooky or weird about this. We're going to talk about weird first now. So why do I show you 2 dice? We all use dice, right? We've probably played with dice in some games. Maybe like me, you've tried desperately to get out of jail by rolling the right 6s. Maybe it worked. In my case, it didn't. But there's still nothing weird about this. But now imagine living in a world where your life is dictated by rolling dice. Where if somebody asks you a question, you can't answer unless you roll dice. So let's say I'm asking you, how are you feeling right now? Well, you would pay attention, maybe go, I'm sleepy, or I'm excited. But what if I tell you that's not allowed? This is not how the world works right now. You have 6 possible ways how you could be feeling. Maybe you're feeling cool, or silly, or sleepy, or excited, or angry, or scared. But you can't answer my question until you've rolled a dice. Not this kind of dice, not the Monopoly dice, but a dice like this that has these emotions, these feelings on there. So you would have to roll this dice to answer my question. So let's do this. And my dice says cool. So now that I rolled my dice, I can say, well, you're asking me, I feel cool. But honestly, I could have gotten a different outcome because I had these 6 different possible outcomes. And that's a really strange way to think about a life where maybe you can't really say how something is until you measured, until you looked. Because all you can say is that at this moment, you could get any of these outcomes. And this is what we call a superposition. That's a really big thing in quantum. And all it really tells us is that if somebody asks us, if we're measuring, if we're trying to find out, any of these 6 possibilities could happen. I could say I'm scared. I could say I'm excited. So thinking about a world where you're living like this, that seems weird, right? And you might ask, when does this even happen? And this is exactly the quantum world, the subatomic world. When things are really, really tiny, this is how this all works. And quantum physics, that's probabilistic, which means you're only living in probabilities and odds. So you can only say something like, I have a 30% chance that I'm angry and a 70% chance that I'm happy. And if I want to know which one it is, I have to measure, and then I'll be either angry or whatever the other option was I said. And so that's something that is strange and weird. And when they first discovered that this is how this works at these scales, not everybody was very happy. For example, Einstein, he really wasn't a fan. So he said, it's one of his famous quotes, I, at any rate, am convinced that he, God, does not throw dice, because it just feels so unbelievable that there would be all these probabilities instead of really knowing what is going on. But honestly, it doesn't really matter if we are comfortable or not comfortable with this, because we actually figured out a way to use this, to do something with that. And that's where quantum computing comes into place. So how is a quantum computer different from a classical computer? I mean, it looks very strange, and this is only one of the possible ones that we have. They all look different, they're all huge, they're all weird. So let's look at a classical computer first. The computers we all work with, they store information in bits. So 1 bit is 1 piece of information. And this bit can either be a 0 or a 1. So if you put your name into a computer, the computer translates everything into 0s and 1s. And a good way to think about it is this little switch here. If the switch is in the on position, that would mean the value is a 1. And if it's in the 0 position, in the off position, that is a 0. And if I check, it's a 1. There's no uncertainty right there, or it could have been a 0, but it's set. A quantum computer uses a quantum bit. We call this a qubit, and that's different. It can still be a 0 and off, or a 1 and on, but it could also be like in this little dimmer here, it could be somewhere in between. So in this case, when it's right in the middle, that would be a superposition state, like earlier when I talked about these feelings. This little cloud would tell me, I actually can't say anything more than if I measure, if I ask, what value are you? I have a 50% chance of getting a 0 and a 50% chance of getting a 1. And the crazy thing is, because I can store more information in a qubit, 1 qubit can take 2 pieces of information. If I just have 100 of them, 100 qubits, I can store more information than all the hard drives of the whole world. And I'm sure there are more than the ones I did, but at some point I was like, this is enough, I'm making more computers. And if I take 300 of them, then I actually can store more information than I have atoms in the universe. And that's an insane number. I think it's 10 to the 84. Don't ask me how they know this. but it's a lot. So 300 qubits. And all of this because I can make this qubit be in the superposition state, where I just can only say, I might get a 0 or I might get a 1. So keep in mind, this probability or this capability of having these two pieces of information, that's only until I look. Because if I look, I'm going to get either a 0 or a 1, and then I lose my special feature, my special quantum feature. It's like flipping a coin. And what can we do with this? We can use this for quantum computing. And I said earlier, as my intro, quantum computing might help us solve the cat puzzle, right? That's something we could do. We could go through these 95 billion possibilities in 1 second, but we can do more. We could, for example, figure out what's the fastest way from Flagstaff to Disneyland. And differently to a classical computer, we could look at all of these different routes at the same time and just get instantaneously the correct one, the fastest one. Or I could use it for drug discovery, and I could look at all these different combinations at the same time. So basically anything that is very complex, like climate change, that's really good for a quantum computer. I could also use it to factorize number. For example, 546, that's 3 times 7 times 2 times 13. That's something I can do with a quantum computer. Okay, so this sounds good, and it is. Factorizing is good, but there's a downside. A lot of our encryption relies on factorizing. And so if we can use a quantum computer to factorize things, that means we can decrypt and we can hack and we can steal secrets. So that's not so good. So there's a downside, right? There's some risks we are getting with quantum computers. But luckily, we can use quantum physics also to protect our information. It turns out we can use light using quantum physics to send very secret messages. And understanding how this works is actually something we can do by looking at things in our environment. You've probably been at a lake at some point, right? And you've looked down and then the light shines onto the water. Even if the water is very shallow, maybe you just see the reflection of the trees, or you see your own reflection. You don't see what's in the water. And if you're lucky, you have something like this. You have polarizing sunglasses. Fishing, people who go fishing love them, because what they do is they filter out certain light. And by doing this, you can suddenly see what's actually in the water, because you can remove these reflections, you can remove the glare. And we can actually, with quantum physics, use these polarizing sunglasses to send secret messages. So you have to be fair. You can't just do it with a flashlight and sunglasses. You need to find a way to have your light so reduced that it's only one photon, the smallest amount of light that you can have at a time. So you're sending one photon at a time using these polarizers, and you can send these secret messages. And there's something else that's cool. If somebody was trying to spy on you, if somebody was trying to look at these messages, your message would change. And so you could actually tell that there was a spy, and you just stop using this. So this is something you can then use to encrypt your data, and nobody can hack it because only the sender and the receiver had this secret message. So this was the weird. Really quickly, I want to talk about the spooky. The reason we call this phenomenon spooky is also because of Albert Einstein. He again wasn't really a fan. This is called quantum entanglement. And a good way to understand what it does, the outcome is if we go back into our pretend world where we are the ones living with these quantum rules. So here are two people, and like before, these people would have to roll a dice to answer how are they feeling right now. And their answers would not be related, right? Maybe I'm asking the first one and he's sleepy, and maybe I'm asking the second one and this one is excited. And the next time I'm asking, the first one is still sleepy, but this time the second one is sleepy too. There is no correlation between the outcomes of when I ask them how they're feeling. But using quantum physics, those are really, really tiny particles. I can bring them together and I can do something that's called entanglement. I can entangle them together, and by doing this, I can link them in a really, really strange way that correlates the outcomes. So if I now ask my first one and he says he's sleepy, I will find that every time I ask the first one he's sleepy, the second one was excited. So suddenly the outcomes are correlated in a way. It's as if they were holding hands or talking, but they're not. And the craziest part is if I take one of them and I put it on a spaceship or something and send it to Mars, this would still work. I would have the same outcome. And it's instantaneous. So it's not like somebody sends a message and says, hey, I'm sleepy, you have to be excited because remember, we're supposed to be in this together. The interesting part is though, they're very, very fragile, these things. So I would actually have to put both of them in really, really cold fridges. And this quantum entanglement, that's not something that we experience, but these quantum particles experience. That is something that will be the main resource for us when we want to build a very new internet, a quantum internet. That's actually something I am working on, making this new internet. And there will be many things we can do with it. Most of them we have no idea yet. Another thing we could do is teleportation. So you might have watched Star Wars, as Star Trek is the right one. Star Trek at some point was like, beam me up, Scotty. So I'm not saying we can beam anyone. We won't beam people because that's way too much information, but we can actually transport information from one point to another. So instead of putting my information in a fridge and sending it somewhere, I can teleport the information from one location to the next. And those are just two examples of all the things that we can do with just the spooky part. And with this, I'm just going to stop. And I don't know if we're ready, or it's coming. Thank you.
Thank you. That was terrific. I don't know how many talks you guys have seen about quantum mechanics and physics, and I'm assuming a few or maybe none, but I'm guessing a lot of them were not necessarily accessible where you could actually follow what the science is. So this is terrific because for people who are not in the field, once we start hearing about entanglement, that's an easy place to get lost. So I appreciate these really interesting pictures. So unfortunately, this Festival of Science, I feel like we've had a couple negative bits of information. So I don't know who saw the keynote, which was a lot of fun, but the speaker came out and said, we're trying to clone things, but then said, we're not cloning dinosaurs, so we can't. So there's a lot of sad faces, but still can do some amazing things with cloning. And now you just told us that we can't teleport.
Well, we can teleport, just not you.
Okay.
Right? So when I have my students calculate teleportation when they learn it, I always start with the teleport. And then later on, when they realize we're just teleporting qubits, it's like, man, but they did teleport. I mean, they learned how to do it, just not people.
Okay.
Yeah.
So what I got out of this is maybe.
No people.
Well, Ines, that was terrific. I really appreciate you spending so much time talking with us, talking about quantum. It seems like the world's going to change, and just you said yourself, in a way that maybe we don't necessarily know, and we'll find out. But thank you for giving us that introduction. So a big hand for Ines.
Thank you so much for having me.
You're welcome. There we go. Just grab my notes. Okay, we are on to our last speaker. Thank you so much, everyone, for coming out tonight. We're going to finish with John Taylor. John is the founder and executive director of Terrabirds, a Flagstaff-based nonprofit whose mission is to educate and empower youth through gardening to help prepare them as the stewards of a sustainable future. He was born and raised in Flagstaff, graduated from Flagstaff High School. I heard he even went to Seacrest recently, yep. Received a bachelor's degree in the history of art from Yale University and a master's degree in business administration, also from Yale. So, big hand for John.
All right, thank you for the warm welcome and thank you for all the other outstanding presentations. It's a pleasure to be here. I'm here tonight to talk about green schoolyards and why they're important and worth pursuing. And green schoolyards are schoolyards that welcome and cultivate nature on the school campus. I think one of the best ways to understand a green schoolyard is by what it is not. And that's the schoolyards that many people in America and even here in Flagstaff grew up with back in the day of kind of think asphalt and kid burnt cinders. I went to Sechrist just outside the door here, and at that time, that playground was just entirely cinders. Luckily for me, the forest was right outside the door, so we did have nature. And in my sister's grade, there was one of the buffalo got loose back in the 70s. So for a brief period, there was a buffalo. So that's pretty cool nature. But the reasons to have green schoolyards are because nature is our best teacher. And nature, as we know, inspires curiosity. And it's an entry point into science and our relationship with the world. When it comes to food in school gardens, research has been done that when kids help grow food, they're interested in eating green food like vegetables and things. And I've seen that with my own eyes quite a bit. I also want to talk about equity and access to nature. Like I said, here at Sechrist, I had the National Forest, and in the family that I grew up with, I got to go to the Grand Canyon. I got to go hiking. I had nature in my life every day. I can't tell you how many young people I've worked with here in Flagstaff who have never seen the Grand Canyon. They've never been up on the peaks. There are quite a few kids I work with who've never been to the Buffalo Park. So if you don't have families that are helping you cultivate that relationship, having access to nature is not something that we, can take for granted. I also want to talk about daily access. We're lucky here and in many places to have field trips and get to go visit nature. And those are, of course, great and important. There's also a lot to be said for daily access to nature. And a great example is at Ponderosa High School here. Our first period steward class has started to revolve around an orb weaver spider that we've been visiting and feeding every day. And in the process, finding another one, and now another one. And now we have about 20 spider nests that we visit on a regular basis. And we're comparing the sizes of them and the difference between males and females and conjecturing about, what's happening and finding their egg sacs. So it's that daily access to this nature that's really making a difference. And in this case, students who might be more interested in their phones are finding a definite curiosity in this class. It's just an example. The other reason for green schoolyards is just learning styles. Many people learn well with books in the typical classroom. Many people learn better with their hands, with their eyes, and sensory relationship with the world. We work with a lot of kids who don't thrive in the classroom, and then their teacher says, oh, Jimmy's doing so well and is now a leader in the class and is performing beautifully, and because this student is able to thrive out there in nature at school. Nature is also our best therapist. Having natural infrastructure at school, seeing butterflies, seeing birds, being around trees is, needless to say, helps with anxiety. It helps people just feel better. Nature at school is also a great form of climate action. When I went to school, I remember watching a movie about the rainforest and seeing the thing at the end where it said, oh, in the time it took to watch this movie, 10,000 acres have been destroyed, and feeling horrible about that. And sometimes climate anxiety affects young people, but then it's hard to know what to do about it when we hear about this stuff. But dealing with nature and taking action about, environmental issues and whatnot on a daily basis through taking action at school really helps young people feel empowered and hopeful, and develop some skills and knowledge that they can take out there into the world with them. And then lastly, want to just mention culture. The typical kind of, American schoolyard is pretty flat, and one of the opportunities we have on schoolyards is to represent and celebrate and make feel at home people from all different kinds of cultures and backgrounds. We're working on a project, trying to support a project at Flag High right now, where we're converting one of the courtyards into kind of a mini Hopi land with a small Hopi house and a plaza and then working towards planting Hopi crops and representative Hopi plants that mean something to those students to help them feel a sense of place at the high school. So these are just examples of why green schoolyards are important. Let's talk a little bit about how to go about designing, building, and stewarding green schoolyards. This is where Terror Birds comes in. My background is in landscaping. I had a small business and also doing wetland ecological restoration. I had a client ask if I would do a garden program with her 4th grade class back in 2009. And after literally that first day, I found, kind of like the gentleman with the caves, I found that this was my calling and started doing it ever since. And the way that I've approached school gardening is not to build gardens out for kids, but kind of like teaching to fish, building it with the kids. And that's been the reason to form Terror Birds, is to support school communities and teachers in leading garden programs in the schools. We go in there and for 6 or 8 sessions in the spring and 6 or 8 sessions in the fall, we'll work with school communities to engage the kids in visioning, designing, building out, and then stewarding these green schoolyards themselves. We also have an after-school youth jobs program for high school students to get paid to do this work. But the key point is here is we design big projects, not small one-off little garden plot, but go for a big vision to really transform school grounds and engage kids in stewardship of that. And in so doing, we talk a lot about legacy. So what you're doing today, we're not going to finish this. We're just going to get it started. And this project will carry on for years. This picture of Ponderosa High School is an example. That first picture up in the upper left-hand corner was in 2011. This is the site roughly now or a year or so ago. And we've been working on that for 13 years now and still going. So the other way we approach this is just through teaching hard work, safety. Kids' favorite thing about our Terror Birds work we do with them is they get to use the pickaxe and use adult real tools. And it's amazing how important that is to young people to be empowered to do the work themselves. I think last spring's best story for me was working with the 5th graders at the new Killip school. As many people know, they were quite literally up to their knees, flooded out of their old school, had to leave there prematurely, went to the other side of town. When they came back to their brand new school, granted, it was a beautiful new school, but it was also a pretty sterile environment. And those 5th graders set about building out the new garden, along with kids from all the grades, I want to say. But those 5th graders moved in about 18 cubic yards of soil, built 12 raised garden beds, planted trees. And by the end of their spring, a whole new life was arriving in Killip. And for them to go through that and to be part of the change in the new Killip was pretty exciting for them. Want to talk about resourcefulness. We also try to really teach young people to just be resourceful. We don't always buy our way out of or into projects or always need money to go get stuff. Learn how to be resourceful and make do with what you have, make do with the skills in your community. We gather leaves from the neighborhood to make mulch, just simple things like that to teach kids that you can find what you need to make the world happen the way you want it. The other way we do this is through teamwork, either directly or indirectly. We work with a tremendous host of partners, and I really celebrate Flagstaff for this. I think we do a great job. Festival of Science is an example of that. But we work closely with the University of Arizona Cooperative Extension Service, ETA, Hopi Levi, and Deborah Onse. We work with Native Americans for Community Action. We have Camp Colton, Willow Bend, Grand Canyon Youth, Arizona Trail Association, Colton Community Garden, the Just Cultivate Coalition, Townsite Urban Farm, Food Link, Flag Cooperative Preschool, the Rising Leaders Program at Grand Canyon Trust, NAU Sustainable Communities Program. These are just some of them, but I bring them up because it's all together. We form this continuous track of nature experiences, for our Flagstaff kids. And what Terror Birds niches in that is providing that daily green schoolyard. I did not list all of our school partners because there are many of them, but I do want to mention Ponderosa High School here has been our host for all these years, and they're our work family, if you will. Another way we do this is through coalitions and through kind of national outreach. I want to give a shout out to the Children in Nature Network and the National League of Cities. They've welcomed us into something called the Cities Connecting Children to Nature Initiative. And together with Flag Unified School District, the Cooperative Extension here, and the City of Flagstaff Sustainability Department, Terra Birds is part of this Green Schoolyards Flagstaff that works together towards this vision. And we're presently working with the NAU Geospatial Research and Information Lab, NAU GRAIL, to create an interactive GIS story map of not just the schoolyards, but any kind of youth nature education sites in Northern Arizona, so that we can, using pins and call out boxes, highlight features of these, but then also zone out the grounds of the schools so that we can start to create different maintenance protocols and kind of create a separate category from regular, maintenance, if you will, let's say FUSD, and create a youth stewardship maintenance category so that we can more efficiently engage young people in being stewards of their school grounds, and in many cases, hopefully pay them. So what do we get after we create these green schoolyards? We get food gardens, we get habitat areas, we get natural areas, we get sustainability demonstrations like rainwater catchment, stormwater management. We get culturally welcoming and educational campuses for people from different backgrounds, from a variety of backgrounds. So in summary, these green schoolyards are outdoor learning laboratories. They're an extension of the school out to the very property edge of the school, we hope. And these are STEM labs where people can practice the STEM skills of teamwork and patience, problem solving, critical thinking. They're an extension of the gym for health and wellness activities. These schoolyards are like a civics lab, because when you have a school garden, you have to cooperate and decide who's doing what, where, and who gets to do what, who makes the decisions, who's deciding what weeds do we pull or which ones do we leave for habitat, things like this. So these are civics opportunities. And most importantly, these schoolyards are beauty. They're prideful and they're hopeful landscapes. I think I counted when my son went from the co-op preschool to 5th grade at Marshall, he walked up and down the Marshall garden, probably 6,000 times, not to mention the after school times. So if you look at those as advertising impressions, walking up and down that garden gave my son and other kids at Marshall a vision for how the world can be, as opposed to just a stark hard pan, dirt. So, and also, most importantly here to this discussion, we get healthy, well-rounded kids and hopeful kids who've developed some skills, who've learned a little bit about who they are by being outside in the school garden. One of my favorite memories is a young man named Luke who never really worked. He never really did much, but he was right in the middle of building out the Puente School Garden, and he was a comedian, and he kept everybody laughing and engaged. And so, working in the school garden helps us figure out a little bit about who we are. So last but not least, I'll just close with people have asked about the name Terra Birds. Where does that come from? I think that birds are kind of universal symbols of transformation for humans. For millennia, we've been naming our spiritual traditions, our sports teams, our mascots after birds. And I think it's because birds inspire us. Birds fly. Birds have a sense of humor. Birds talk. They build homes. They partner for life. They migrate. They come in myriad shapes, colors, and sizes. So I think birds are amazing mascots for us. And they're also amazing symbols of transformation, whether you think of it spiritually or evolutionarily. Birds are survivors and have transformed from dinosaurs or from the ashes, however we want to look at it. Birds are symbols of transformation. So they certainly inspire me, and I think they inspire kids. So hence the name Terra Birds. there's an acronym in there of being innovative, resourceful, dedicated stewards, which embodies a lot of the values we try to work with kids. And I'll just close with just saying our vision is we hope that every school has a green schoolyard, and not only has one, but that every kid in his or her experience at school gets a chance to, help steward these, help create them, and truly have a daily relationship with nature on their school grounds. So with that, I thank you. And
Thank you, John.
Really
Really well done.
thank you.
Something I find really interesting about terror birds. We talked a lot about, can we get kids out to nature, go on a hike? I don't know how many kids you try to convince us to go on a hike. It's not easy. Or like you said, we live near the Grand Canyon. What can we do? I hadn't really thought a whole lot about, well, let's just bring nature to kids. And that's what you've done. So I think that's amazing. Especially a lot of our parents, it's, well, we got to go to soccer and then hockey and then figure out how to get a second job to pay for hockey. Maybe have a wife who works a weekend or two. Well, my question is this. I love that you and your organization are bringing nature to kids, and not just they get to see it, but they actually put their hands into it and they're physically interacting with it. How do you balance living in an arid area like we're in right now with the water and resources necessary to build these gardens at the school? And if just be careful, if you are rethinking everything you've done because of this question, please don't.
No.
Just keep going.
No, it's a great question. I'm glad you asked. Interestingly, we typically don't use irrigation systems. I'm not against them. They can be very efficient. Learned from Brad Lancaster's presentations down in Tucson, that oftentimes, up to half of a municipality's water use comes for outdoor irrigation. There's an energy and therefore a pollution relationship with that, and all the energy that's used to move water around. So we really use these green schoolyards as an opportunity to practice and model. Rainwater collection when we can, but that can be expensive to buy tanks. But a lot of these passive water techniques, using swales and berms and basins to, observe and gather and capture water in ways that we can. So that's been a big part of the design and the work for kids to do on these schools, is to make those observations and manipulate, kind of terraform their schoolyard to capture this water. Mm-hmm. And then I also want to mention soil. We spend a lot of time in our programs talking about soil. Is kind of very unappreciated, I find, in our culture and in our educational environment. A lot of the soil education is dictated by kind of the NPK model. I love the drawings we saw tonight of the soil food web for that reason. People don't even know those critters exist. And so we talk a lot in our Terror Birds programs about, and we're constantly trying to cultivate healthy living soil, imagining what's in there, and then realizing that it's that living soil that creates spaces for water to enter, organic matter to hold that water, life that helps move that water around. And so it's amazing how the living soil in these schoolyards actually, conserves water and allows, like the picture here of Ponderosa High School, the water in the pictures from a stormwater coming off the street and the surrounding vegetation. We never hand water, and it's not on an irrigation system. That's all just water, kind of our own little mini aquifer right there on the site. So it's a cool thing about the green schoolyards, is we can practice all that.
That's amazing. Well, thank you.
Thank
you
you
for
so
sharing
much.
your story.
Really appreciate it. Thank you.
Tomorrow, plein air is a naturalist drawing activity. It's actually going to be at the Terror Birds Garden at Ponderosa High School, right?
Yes, correct.
Bad weather tomorrow, so it's been moved. Again, I want to thank you for being part of the festival. I want to thank all of you for being part of the festival and coming out tonight. Thank you, everyone online. Hi, Mom and Dad. Thank you for watching. We'll be out here for a couple more minutes if anyone wants to come and talk to the speakers, has questions about more things with the festival, but otherwise, I wish you guys a great night. I ask you to do the survey. I know. Please take one of the slips, go on the website, go on our app, take a survey, provide us with information so how we can provide a better festival, and your testimonials help us secure funding. So thank you and have a great night.